Hello everybody, Gadget Boy here, and welcome to the first of a series of videos that I'll be doing, just explaining some of the basic components you'll see in electronics and how to identify and test them. And today we're going to be talking about resistors. They are pretty much the simplest component you'll find in any piece of electronics. And their entire purpose is to resist the flow of current through a circuit so that things don't blow up. One of the most common uses of a resistor is to limit the current through an LED. I'll give you an example. Let's say you want to power an LED off of USB. You'll see these little USB LED lights all over the place. And it's not so simple as just taking an LED and plugging it into the USB port, because the LED will soak up a certain amount of that voltage and then start pulling current, and it doesn't know how to stop pulling current. So at 5 volts, a 3-volt LED is going to heat up and then self-destruct as it pulls too much current. So we'll put a resistor in line with that LED to prevent it from destroying itself. So there's a neat little equation we can use to determine the size of the resistor that we need. So we're going to look at this here. R is the resistor equals the voltage source minus the voltage dropped across the LED over the current. Now, most LEDs, and I'll show you an LED package I've got here, will have a maximum current draw here and their typical current drop here. So we're going to use that information in our little example here. We're going to go back to R equals, now our source voltage, USB power, is going to be 5 volts minus the current, or the voltage drop across the LED, which in this case is 3.6, and we want that to be 20 milliamps, or in the case of the way these equations work, you're going to want to put 0.02 for 20 milliamps. Now we're just going to reduce that a little bit. So R equals 5 minus 3.6 is going to be 1.4 over 0.02. I can't do that part in my head, so pardon me while I grab a calculator. 1.4 divided by 0.02. And in this case, we're going to want a 70 ohm resistor. Now, another very important thing is to make sure that your resistor doesn't burn out. So we're going to look at another series of equations for this resistor here. Where power dropped across the resistor, we've got a 70 ohm resistor, 70 ohm, and we've got 2 milliamps, so this is going to be the wattage dropped across the resistor. So going back over to our calculator here, 0.02 squared times 70 ohms equals 0.028 watts, or well, 0.2 of a watt there, or 2/100ths of a watt. So you can use an 1/8 watt resistor in that situation and not have to worry. But if you pull a resistor that doesn't have sufficient wattage, then the resistor will heat up like the LED would have, and it will self-destruct. So that's just a quick explanation of what resistors are and why we use them. Very simple explanation. They have far more usages that we'll get into in later videos as we start exploring more complicated circuits. Now the next thing is identifying resistors. Now I've got a pile of components here that's actually part of a kit that I'll be building as in part of a next video. And resistors have a series of bands on them that are all different colors. Those colors help you determine what the value of that resistor is. They come in a couple of different types, and I've actually got a couple of examples here. These are actually ones from the kit. These are ones that are not from the kit because I wanted to show you both types. Now, bear with me a moment here. This might be a little noisy, and the camera's going to go blurry as I attach this little microscope thing I've got. Just bear with me a second here as I get it centered. Okay, so we'll start with your basic resistor. Now this one, I get it up in there. We've got little bands there. We've got yellow, purple, yellow, and then gold. I'll explain what those mean in just a moment here as I show you one of these other resistors here. Now, these ones are a little weird. These are high precision resistors, which can actually be a bit of a pain to identify, and I'll show you why in a moment. Now this one you'll see we've got orange, orange, black, brown, and then a brown. We'll explain the difference between these resistors with the 5 bands and the other resistors with the 4 bands. Now, these precision resistors can be a little bit of a pain sometimes to identify when you have, and I'm trying to find one of them here, just a series of brown and black stripes on them, such as this one here, because this resistor could either be read as brown, brown, black, black, and then brown, and the last band is the tolerance, and we'll explain that in a moment, or it could be read as brown, black, black, brown, and then brown. In this case it is brown, black, black, brown. If you're ever in doubt of the value of a resistor, you can always measure it with your multimeter rather than reading the stripes there. So, now to explain what these stripes actually mean. Just pulling off this microscope again. There we go. Wait until we get focused. I made up this neat little color-coded chart here, and I'll just go over the way this works. Now, there are a bunch of mnemonics out there to remember the order of the colors here. The one that I was taught and have never been able to learn a different one was slightly ribald. It was taught to me by my father, who was in the Air Force, and he learned his when he was repairing color TVs way, way, way back when they still had tubes in them. Anyway, so the colors are brown, or black, brown, red, orange, yellow, green, blue, violet, gray, and white. G looks kind of messy there because I was trying to make a gray pen mark, but it didn't work too well. and each of those correspond to a number. And to remember those, you can use any number of mnemonics. Mine that I learned was bad boys rape our young girls, but Violet gives willingly. And that latched in my brain, and I've never been able to forget the resistor color code ever since. And then you'll sometimes have a metallic band or no band at all. Sometimes you'll just have 3 bands on a resistor, and those are the tolerances. So gold band means that it'll be plus minus 5% of the given value. Silver band will be 10% of the given value, and no band will be 20% of the resistor band value, and those are pretty crappy resistors. You don't want to have a 3-band resistor in any sort of precision electronic. And then in the case of these blue ones with the 5 color bands, what you'll actually have is, well, we'll start with I'm getting ahead of myself here. We'll start with the 4 color band resistors here. So we're just gonna set my little chart aside now, because you guys have had a nice look at that. So we're going to look here at this actually rather colorful resistor here. And what we have here is we've got a yellow, purple, yellow, and then gold. Right? Yes. Okay. So, in this case, these numbers are 4, 7, and then 4. And the way you use those to identify a resistor is you take the first 2 color bands and you go 4, 7. And then this 3rd color band is how many zeros follow those first 2 numbers. So in this case, we need 4 zeros. So 4, 7, 0, 0, 0, 0. So, and this reading is in ohms. So what it's saying is that is 470,000 ohms, or as we would say, 470 k ohms. Now, in the case of these precision resistors, with the 5 color bands, let me pick a good one here. Oh, actually, we'll pick this one here, because it's actually the exact same one as the same value as my example here, but it's got 5 color bands instead. So this one with 5 color bands has yellow, purple, black, orange, and then the brown color band, which in this case actually means it's 1% tolerance, because in this case it's and I could be wrong on this one, because I can't ever remember exactly how it works, because I encounter these precision resistors so very rarely. But the multiplier basically corresponds to the percentage of tolerance on it. So 1 to 9 or 1 to 10%. But that's kind of, that doesn't really matter. If you've got a blue resistor, it means you've got a precision one. It doesn't really matter to most hobbyist electronics. Anyway, so yellow once again is 4, purple is 7. What did I say it was a brown stripe? Or black stripe. So black is 0. And then orange is 3. Now, in this case, the first 3 color bands are your digits. So 4, 7, 0, and then the 4th color band is how many zeros follow that one. So 0, 0, 0. Once again, 470,000 ohms, or 470 k ohms. So that's how you identify the two types of resistors. Well, the two main types of resistors. Like I said, there is just a 3-band resistor out there, which would work just like the 4-band resistor, only it's got 20% tolerance on it. So they're pretty junky resistors. Next video, I'll probably identify capacitors and how to identify them. If you liked the video, give me a like, comment, share it with your friends, and I will see you next time. Thanks so much for watching.